Okay, in my last video we worked on converting rectangular form equations to polar equations. That is, if we were given some point, some y is some function of x here, and we're listed as a series of points x, y in the coordinate plane, could we really relate these to some r and some direction theta? Essentially what we want to do in this video is we're going to have this r theta. That is, we're going to know how far we went and in what direction we went in to get to this point. What we want to do is use that relationship between x and y to convert it back into rectangular form. So let's go ahead and point a few things out here really quickly. Given some general point where we have some r and some theta, we can look at it this way. We say r and theta. R theta. We are going from polar form back into rectangular form. So what we want to do is relate this to x and y right here. And we could say that at least in terms of how x, y, and r are related, let's recall that x squared plus y squared equals x squared plus y squared equals r squared, where this is our polar length here, and then we say that the direction angle here, theta, would be related to x and y in a way that, it'd be tangent of theta is y over x. So having this in the back of our heads here, let's go ahead and take a look at a couple of special instances where we want to convert from polar to rectangular. So when we say r equals 2, in this case right here, you'll often see r is equal to a constant. And basically in the polar coordinate grid, we would say here's a radial length of 1, here's a radial length of 2, and so on and so forth. We would say that the r equals 2 graph would really look like a circle of radius 2, because any point on the outside of this, no matter what the r value is, no matter what the theta value is going to have an r value of 2. So essentially, what would this look like in rectangular form? Whenever you have an r value solely and then a constant, what we're going to do is we're going to square both sides. So it would follow that r squared equals 4. And what we're really doing was we were converting to the r squared so that we could really substitute in an x squared plus y squared here. So we get x squared plus y squared is equal to 4. And then everybody can kind of easily see that, and we could list this in conic section form. You can see that this is a circle, that's centered at hk is 0, 0. And has a radius of 2 in either direction here. So that is how you would deal with r equaling a constant. Now if you have an angle like you have here, we have to recall that the angle is related to x and y thusly. So the tangent of whatever that angle is going to be equal to y over x. So our goal here is really to be able to say that the tangent of this angle, tangent of pi thirds, would be equal to y over x. Okay, this is very true. So we would say, okay, well, the tangent of pi thirds, if we look at the unit circle, we'd say here's pi sixth, pi fourths, pi thirds. And so pi thirds right here, I could say that this is 1 over 2 comma root 3 over 2, and that its tangent value is root 3. So we would say that root 3 is equal to y over x. Now, this is the weird part about this, but what we want to do is we want to isolate y now. And so I'm going to take both sides of this times x, and what we end up with is this. We get y on the right, and then we would get the square root of 3 times x on the left. And keep in mind that really what we wanted to do was get our rectangular equation. So in either instance, if you're dealing with a radius length here, square it out and then substitute an x squared plus y squared. And if you're dealing with an angle, take the tangent of it, and we know that that has to be equal to y over x because of our relationship between x, y, r, and theta. Cheers.